Howdy everyone! In this video, we'll go over the idea of one-sided limits in calculus. Let's go! Let's analyze the graph of y equals f of x with limits. There's a problem though. This isn't like other functions that we've seen. There's a jump at x equals 2. The question then becomes, can we find the limit of this function? Well, sort of. We have to use a new type of limit called a one-sided limit. With that, we take the limit from either the left or the right side. Let's say we took the limit of f of x as x approaches 2 from the left. We use the usual limit notation, but with a little minus sign as a superscript. Why a minus sign? Think about what left means on a number line. The more to the left a number is, the more negative it becomes. Since left and negative have that association, we use that notation. As for taking the limit, it's as simple as regular limits. We just look at what happens as x gets closer and closer to 2, but this time only from the left side. As you can see, the function approaches y equals 2. Thus, that's our limit value, a simple 2. Let's do the other side. We'll take the limit of f of x as x approaches 2 from the right. It's written like before, but with a plus sign instead of a minus sign. The reason is similar. On a number line, if you stand to the right, you'll be more positive. Now for the limit. If x approaches 2 from the right side, y approaches 3. Therefore, our right side limit is a nice and clean 3. At this point, we're left with something a bit weird. The limit from the left side doesn't quite agree with the limit from the right side. That's a problem for taking the limit of f of x as x approaches 2. We're getting two different numbers from two different directions, so we can't just choose one and call it quits. When something like that happens, we say that the limit does not exist, or DNE for short. Think about two friends who always want to be right. Friend number 1 says the limit, according to the left side, is 2. Friend number 2 says the limit, according to the right side, is 3. As I'm sure you know, whenever you have two people who always need to be correct, no one wins. Getting DNE for a limit brings up an important logical property, that being the limit of f of x as x approaches a, where a is just some value, is equal to some value L if and only if the left-hand limit of f of x as x approaches a is equal to the right-hand limit of f of x as x approaches a, and both these limits are equal to the same value L as before. So what the heck did I just say? Well, this logical statement says that a regular limit exists only when the two one-sided limits are equal. If they're not equal, the limit does not exist. When they are equal, the value of the limit is just the value of the one-sided limits. And that's a great result because it's pretty much what we saw on the last graph, so we know our logic is correct. Now let's check if that logic still applies with a normal graph like y equals g of x. We'll try the left-hand limit of g of x as x approaches 1. If we approach x equals 1 from the left, we'll see the function approach y equals 1. Trying the right-hand limit of g of x as x approaches 1. If we let x approach 1 from the right, y approaches 1. We see that both one-sided limits are equal. That means that once we take the limit of g of x as x approaches 1, its value will also be 1, since that's the value of both one-sided limits. So yes, our logic here does hold. You might be wondering, are there any functions that have jumps like the one we saw earlier? Actually, there are, and one of them is h of x equals the absolute value of x over x. Let's draw out the graph. To the right of the y-axis, all x values are positive. That means the absolute value of x over x will effectively just behave like x over x. As you know, any number divided by itself is 1, so we should expect a function that is just a constant 1. To the left of the y-axis, all x values are negative. Because the absolute value is always positive, it'll be like before, except it's a positive number divided by a negative number, which is ultimately negative. And x over x with one negative number ends up always being negative 1, so we should expect a constant negative 1. Now let's do our magical calculus at x equals 0. From the left side, we get a limit of negative 1. From the right side, we get a limit of positive 1. Since the two one-sided limits aren't equal, the limit of h of x as x approaches 0 does not exist. So that's a cool little example of a function that naturally has a jump like this one.